Okay, Solomon, let's take a look for this question, this task. Okay, and let's read the question. The speed of the sound is typically given as 767 miles per hour, but that value is only accurate if the temperature is 68 Fahrenheit degree. We can calculate the speed of sound as, okay, in the function, so this is a key information, okay, where T is the temperature in degrees Fahrenheit and K and C are constants. The table contains some values returned by this function. So first of all, we need to determine the values of the constant K and C using the table below. Okay, good. So we have 5 data points, right? Here, that's really important for us choosing the appropriate data point that make us easier to find out the value. So the first one I find out this one is very good. The temperature and the speed of the sound in the air. Okay, so let's try this one. The sound of the air is S equals 0 equals square roots of K negative 460 plus C. Okay, so because K and C they are constant, right? And we know K cannot be 0. So by this one, we can easily know C equals 460. C equals 460, right? Because this one must be 0. The K cannot be 0, okay? And that will be your question, okay? You give, that's a question mark. Why we can write down this one? We plug in the temperature and the speed of sound in the equation. And this one must be 0, so the whole thing can be 0. C equals 460. Yeah, that's right. C equals 460. That's the first one. And after we find out the value of C, I prefer to choose this data point to find out a constant K. Okay, so S equals 717 equals square roots of K times how much is it? The temperature. So we have temperature which is 0, right? Okay, so that's the equation. By doing the square, yeah, and we need a calculator to find out its value. So and the value will become 1117.6. Okay. Yeah, I think that's how we find out the value. But this equation, you did the same thing, right? 717 and 0 plus 460. Yes, you're doing good. And this 0, right? 0 plus 460. You didn't do a square. Did a square? I don't know. This part is a little bit weird. I know that's a square root of 460, right? But how about square roots of K? You need to do square roots of K. Yeah, and then, or what, kind of weird? This equation is really weird because, uh, like if you try to both square, like what I did here is doing the square on both sides, right? So left hand side 717 square, the right hand side the whole square root square. So the square roots disappear. It just remain like 460K. So this part to this step, yeah, there's a mistake. If you want to do the square, okay, it's very cool. So K, and this one is not, it should be 460, and that will be 770 square. Okay, so that's why you find out the wrong value of the K. Yes, so we have a formula now, which is like square roots 1117.6 and then degree temperature plus 460. Okay, that's it. And then we can take a look, like check the value. Square root of 40233. Okay, let me check the values. Okay. Yeah, it's correct. Okay, good. And then we need to do the question B and C. Suppose one day in Antarctica is the negative 110 degree Fahrenheit, and in Texas is positive 110 degree Fahrenheit. What's the difference of the speed of sound in these two locations? Okay, so I'm doing Texas must be faster, right? That's the speed in the Texas and the speed in here. Okay. Antarctica, right? Okay, good. So that we finding a difference, that would be the value. Okay, see. Okay, see how much longer we take to hear a very loud sound from 5 miles away in Antarctica and then in the Texas. Okay, so the 5 miles, okay, that's a concept about the physics. The distance divided by its speed. Yeah, I didn't find out it's a real value, but you can do it with a calculator. That's the time spent in Antarctica, and then we can find out the time spent in Texas. And the difference, that will be the value. Okay, so that will be this question.